Okay, this is a very quick video about X versus T graphs. I will do a different video about VT graphs and AT graphs. For this one, we'll keep it short and focused. We'll just do XT graphs. Okay, so the first thing you need to know is that when you have an XT graph, the position is the y-axis and the time is the x-axis. So this can be a little dizzying sometimes because typically we say right is positive by convention. So the weird thing here is that if I say an object is to the right, what I actually mean is it has a positive value of x. These are all values that are to the right. It's confusing because, of course, this is the y-axis, so it's up and down. But we will say that an object is moving rightward if it trends upward. In other words, for this graph used to have negative x values. Later, it has positive x values. So this graph is moving to the right. We also say that it has a positive slope, and therefore v is greater than 0. For this graph, we see that the slope is negative. It starts at positive x values. Later, it has negative x values. That means it's moving left. It's moving left. And because the slope is negative, v is less than 0. I have a couple other graphs here just to show you this graph is actually the same as this graph. All I did was I took this point and I moved it down. I moved that point down. This is the equivalent of saying that my initial position is less than 0. Notice it doesn't really change the shape of the graph. All it does is move it down. And you're allowed to basically say your initial position is whatever you want it to be. If you want your graph to start lower, just say, okay, I'm calling wherever it happens to be at t equals 0. I'm going to say that that's x equals -3, for example, if that's what I want it to be. Okay? This is a particular case. Notice that this neither trends upward nor downward. I start at x equals 2. Later, I am at x equals 2. This object is not moving. And notice that it is flat. So the slope is 0, and so v is equal to 0. Flat. Special case. Okay? Okay, so none of these are accelerating. And how do I know they're not accelerating? Because they all have a constant slope. The thing about a line that makes it a line is that a line has constant slope. The slopes of none of these change. What does it look like if a graph has a changing slope? It looks like a curve. It looks like a curve. So what I've done here is I've drawn the same curve twice, and what I've drawn is a line that represents the slope of that curve at a particular point. So this green line says that the slope of the curve, the steepness of the curve there, is negative. It slopes downward. And over here, the slope of the curve is positive. So that must mean that the slope is changing. So here we have a not equal 0. The acceleration is a set of instructions that tells the slope how to change. Of course, another way to say this is a tells the velocity how to change, but velocity and slope are the same thing. So this particular guy, this one here, at first has a negative slope. So I will say that v on this is less than 0. V on this is less than 0. Over here, the slope is positive, so v is greater than 0. That means we are moving from negative values of v to positive values of v. That must mean the acceleration is greater than 0 because I'm moving from negative values to positive values. Okay? What does that mean in terms of what the thing looks like? Well, this has a name. It's called concave up. So smiley faces are concave up. So if a graph has positive acceleration, it will curve up. It will curve up. What does it look like if it has negative acceleration? Well, if it has negative acceleration, it will curve down. Notice in this case, here, the slope is not so steep. It's a negative number, but it's not so steep. If I go a little farther, the slope is now a steeper negative number. It is a more negative number. So v here is less than 0. V here is much less than 0. The number is becoming more negative, and therefore a is less than 0. This shape, when it looks like a frown, is called concave down. The point is that acceleration is the concavity of your x versus t graph. Okay, one thing to point out is just because the acceleration is negative doesn't mean the velocity is negative. The velocity is whatever it is. At this point of the graph right here, the velocity is positive because the graph is trending upward. This graph trends upward and then later it trends downward. So the acceleration is negative the entirety of both of these graphs you're looking at. It's even negative here. What's the velocity when this object is right here? Well, the velocity is constantly changing, but right here, if I wanted to make a line that touched it, holy Toledo, that's a flat line that touches it there. In other words, the object at that point somehow bizarrely is at rest. It isn't moving. Now, just because an object is at rest one moment doesn't mean it's required to stay at rest. It just means at that particular moment, v equals 0. The acceleration is going to tell this number to change, and so the object will move at a different time. The point I'm trying to make from all of this is that the acceleration can be whatever number it wants to be. The velocity can be whatever number it wants to be. The position can be whatever number it wants to be. The velocity tells the position what to do in the future. The velocity says you should go up, so it goes up. The acceleration tells the velocity what to do in the future. The acceleration in this case tells the velocity to go down, so it starts like this and later it goes farther downward. Okay, let's look at a more complicated example. So here's something that, I don't know what it does. It goes up, it goes down, it goes left, it goes right. Let's just look at this piece by piece. The first thing to note is, what is it doing when it starts? Well, observe that when it starts, it is not flat. It is already trending upward. And so right at the beginning, I say v is greater than 0. It continues to trend upward until this point right here. This is its maximum. Its maximum. You can also call the maximum the turnaround point. But what's significant about a maximum is that at the maximum, the velocity is 0 because the slope is 0. It's a flat line there. That means that over here, the object is moving right. And over here, the object is moving left. In fact, the object continues to move left because it trends downward, 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 downward until it comes to another turnaround point. In this case, this is a minimum. So the object has a negative slope in this entire region, and so it's moving left in that entire region. This whole region is moving left. After the turnaround point, what happens? It turns around and it starts to have a positive velocity. So here, the object is moving to the right. It moves to the right in that entire region. And again, right here at this special place, at the turnaround place, the velocity is 0. It doesn't stay 0, of course, and that's because there's acceleration. So what is the acceleration? What is the acceleration of this graph? Well, for I would say from about here to here, it is concave down. It's a frown. It's unhappy. And so this is a less than 0. I say that because the velocity, the slope, starts as a positive number and it becomes more and more and more and more negative. This is very negative. But then at some point around here, it stops becoming more negative and it starts becoming more positive and leveling out. So I would say this is kind of a dividing line right here. Now we're going to go to concave up. A is greater than 0. And it looks to me like this stays concave up for the rest of its life. Concave up. So fancy speak for these terms are called POI, or points of inflection, which your calc professor will talk a lot about, but I don't particularly feel like talking a lot about it. What I want to do is just reiterate that a complicated curve like this, what the goal is you break it up into a series of smaller curves and you just apply these simple rules, which I'm going to summarize here. If a graph trends upward, it has positive velocity and is moving right. If it trends downward, it has negative velocity and is moving left. If a graph doesn't trend up or down, then the velocity is 0. And all three of these are this case. If a graph doesn't curve, then the object isn't accelerating. It's moving at a constant speed, okay? If a graph curves upward, it has positive acceleration and will eventually move to the right. Okay, notice I don't say it has to move to the right. In the beginning of the journey, it has a negative slope. That means it's moving left. What I do say is that if the acceleration is positive, it will continue to work on the velocity until it makes the velocity a positive number, and eventually the velocity will be positive, and eventually the object will move right. And then, of course, the opposite. If the graph curves downward, it has a negative acceleration and will eventually move to the left. Okay, hopefully this video was more helpful than confusing.